The People's Pharmacy podcast is supported in part by CocoVia. CocoVia cocoflavanols support both cardiovascular health and cognitive function by promoting healthy blood flow, transporting oxygen and nutrients to vital organs and muscles, including your heart and brain.
CocoVia now comes in an even more concentrated formula with 450 milligrams of cocoflavanols, 5 times more than the leading dark chocolate bar and 15 times more than the leading cocoa powder.
CocoVia has a proprietary process that preserves cocoflavanols at the highest levels, and the product undergoes rigorous testing at every stage, which allows them to guarantee the highest level of cocoflavanols per serving and to provide the purest, highest quality product possible.
People's Pharmacy listeners can now try CocoVia for 25% off by using the code Peoples25 at cocavia.com. That's COCOAVIA.com. Forever chemicals persist in the environment for decades. How did compounds used for nonstick coatings get into the water? This is the People's Pharmacy with Terry and Joe Graydon.
PFAS stands for polyfluoroalkyl substances. There are thousands of these chemicals used in everything from firefighting foam and water-repellent fabrics to fast food packages and stain-resistant carpets.
Almost all of us have some of these compounds in our blood. Should we be worried?
Dr. Linda Birnbaum is one of the country's leading toxicologists. She'll share her concerns about PFAS and other chemicals that can mess with our hormones.
Coming up on the People's Pharmacy, learn why you should care about forever chemicals.
Welcome to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. COVID-19 is the most urgent health concern in the world. Today, we're not discussing SARS-CoV-2. Next week, however, we'll be bringing you an interview with Dr. Steve Nissen. He is Chief Academic Officer of the Heart and Vascular Institute at the Cleveland Clinic. He'll describe the ramifications of COVID-19 for the cardiovascular system.
Today, we're talking with one of the world's foremost toxicologists. Have you ever wondered who tests chemicals to see if they're harmful? That is what we'll be exploring today on the show. We'll also find out about forever chemicals. What are they and why do we call them that? Do you have PFAS compounds circulating in your body as we speak? If so, what are the implications?
To help us answer such questions, we're talking with Dr. Linda Birnbaum. She is Scientist Emeritus and former Director of the National Institute of Environmental Health Sciences and National Toxicology Program. She's also served as President of the Society of Toxicology. Dr. Birnbaum was elected to the Institute of Medicine in 2010.
Welcome back to the People's Pharmacy. Dr. Linda Birnbaum.
I'm really pleased to be here. It's been a couple of years.
It has been, but we have been talking with you for decades. I think our first interview was when you were at the EPA, the Environmental Protection Agency.
That could have well been. I spent 19 years there.
And tell us what you did there.
I was director of the largest health research division that EPA had at the time. At times, it was as many as 150 people.
What kinds of research were your scientists doing?
We were looking at air pollution and the impacts of different kinds of air pollution on health, largely using rats and mice to test it out. We were looking at the effects of environmental pollution on the immune system, not only air pollutant effects, but contaminants in drinking water or maybe in your food. And we were also looking at what happens when chemicals get into your body. Where do they go? How do we get rid of them? Do they become worse because they interact with our bodies? So we were doing many different kinds of things, looking at, again, different kinds of effects on the body using animals as a model largely.
Now, before we go any further, we should explain your scientific background. You are a...
Well, I would classify myself now as a toxicologist, a board-certified toxicologist.
That's what we were hoping you would say. Our listeners may not be familiar with what a toxicologist does. So can you tell us a little bit about the field? There are some programs where toxicology and pharmacology are combined in a teaching institution. So tell us a little bit about what is a toxicologist? What kind of research do you do? Not you particularly, but in general, and what the role of toxicology is in society.
I look at toxicology as the science of safety, really trying to understand what things that we encounter, whether they're drugs or environmental chemicals or things in our food, how they impact our body. We used to talk about toxicology as the science of poisons because the actual word comes from the Greek.
Toxic.
Toxic. But we really are studying how we can use chemicals safely as opposed to how chemicals make us sick.
So there you were at the Environmental Protection Agency for 19 years, and then?
And then I was recruited to be the director of the National Institute of Environmental Health Sciences and the director of the National Toxicology Program.
And how long were you there?
Over 10 and a half years.
So you've pretty much devoted your entire career to this field and at the very highest levels as director. The person in charge, the buck stops on your desk.
I think that's true. I think I should mention that I really started my real career in toxicology when I came to NIEHS as a tenure track investigator.
So you kind of made a full circle.
I made a full circle, started at NIEHS, went to EPA, and then came back.
Now, it's important to distinguish between an agency like the Food and Drug Administration or even the EPA, the Environmental Protection Agency, and the National Institute for Environmental Health Sciences. Because the FDA and EPA, they can set kind of regulations, rules. They can say, oh, we're not going to approve that drug or we're going to recall that drug. You couldn't do that at NIEHS. Tell us why.
Well, NIEHS is part of the National Institutes of Health. So we are a research organization conducting basic biomedical research. Now, NIEHS has some unusual programs for an NIH institute. We also had a Superfund research program, which is a problem-solving program. And we had the National Toxicology Program, which did involve parts of FDA and parts of the Center for Disease Control and Prevention as well. But we are not a regulation or a policy-setting organization. We are conducting research that we believe will be helpful in making policy decisions based on good science.
Can you tell us what the National Toxicology Program is?
Sure. The National Toxicology Program is a program that was established in 1978 by Joseph Califano, who was the Secretary of Health, Education, and Welfare at the time. And its mission is kind of fourfold. One is to actually test chemicals and other substances for effects. One is to develop new tests, so maybe we can have more relevance of some of the tests that we do. One of it is to collect lots of data and do hazard assessments. And the other is a more recent mission that was assigned to us in 2000, which is really to look at the development of alternative test models. So using non-mammalian test models, using non-animal models, using cell culture kinds of models, and computational models.
So as you look back over the 30, 40 years that you've been doing this, how has toxicology changed as a field? And more importantly, I think for people who are listening to us, the relevance of your work, both at the highest levels of research as well as for the association, for how it impacts their personal lives.
So I think when I first started in toxicology, and I have to tell you, when I was first recruited to NIEHS, I didn't even know what the word meant. I literally had to go look it up. I had been doing some pharmacology, but I really didn't know anything about toxicology at the time. At the time, I think we used to explain toxicology as dosum and countum, which is not a very pretty picture, but it was we would expose animals to very high levels of chemicals and see, first of all, initially, did they get sick? Over time, I would say the discipline has gotten much more sophisticated. It's using many, many different techniques of molecular biology and biochemistry. It's doing more mechanistic work, and it's doing more extrapolation work using some of the in vitro approaches, using some of the computational approaches, using alternative models, not only rats and mice. And we're also beginning to look at issues of trying to understand why one person gets sick and another person exposed to the exact same chemical does not. And really trying to understand the differential susceptibility that occurs in people either because of their genetics or their age or maybe their lifestyle.
Dr. Birnbaum, you just mentioned that toxicology has become more interested in mechanistic research. And it sounds like a normal word, but I'm not sure that we all understand it. When you say mechanism, what kind of mechanisms are you talking about?
We're trying to understand how a certain chemical, drug, causes a specific effect. What are the biochemical and the molecular changes that occur in the cell, in the tissue, to bring about the adverse effect?
Thank you.
Let's get very specific, because you have studied a whole bunch of chemicals, and we're going to talk about as many of them as possible, but we're particularly interested in something called PFAS. What are they? Why should we care about them? And getting to the point Terry just made about mechanism, the idea of, looking at the toxicology, but also at the mechanism so we can actually understand how good is the evidence that these PFAS chemicals could be problematic.
So PFAS are a huge class of chemicals. There are nearly 5,000 of them that have been synthesized commercially, and there are more that are just being produced by atmospheric breakdown of many more complex ones. But what they are chemicals where you have the carbon-fluorine bond and you have lots of fluorines and usually lots of carbons. The problem with them is they are called the forever chemicals, and that's because the carbon-fluorine bond barely occurs in nature. There's no easy way to break it down. So these chemicals are essentially with us, certainly for the total future. That's really what the concern is.
What are they used for?
Well, PFAS used for many, many things, especially in modern life. They're used as lubricants. They're used as water repellents, stain repellents. They're used in food packaging. They're used in, for example, our clothes to provide largely things like stain resistance or stain repellency. They're on our carpets. They're on our chairs. They're pretty much everywhere today in our environment. And the CDC, which measures a small number of these only in the American public in a statistical fashion, so we know it's representative. Essentially, everybody has them in their bodies today.
Now, I've heard they're also used as flame retardants.
So the PFAS are one of the, they definitely are used as flame retardants, especially in something called AFFF, or air firefighting foam. And this is the material that is usually sprayed when you have a fire, say near an airport or near different kinds of electronic equipment to put the fire out. Unfortunately, the heavy use of the AFFF, which contains about 3 to 6% of PFAS, has led to contamination of our drinking water and our groundwater in many places in our country.
You're listening to Dr. Linda Birnbaum. Having retired, she is Scientist Emeritus and former Director of the National Institute of Environmental Health Sciences and the National Toxicology Program. She has also served as President of the Society of Toxicology. Dr. Birnbaum was elected to the Institute of Medicine in 2010.
After the break, find out where you might encounter PFAS in your daily life.
What sorts of problems do PFAS cause anyway?
How do scientists find out about the hazards?
It seems like low doses would be a lot safer. Is that an illusion?
We'll also discuss the precautionary principle and how it's applied in Europe as compared to the U.S. You're
listening to The People's Pharmacy with Joe and Terry Graydon. This People's Pharmacy podcast is brought to you in part by Verizana.com.
Verizana Lab offers home health tests that allow you to monitor your hormones and health conditions. You can take control of the quantitative assessment of your health and learn about male and female hormone balance, the stress hormone cortisol, leaky gut, gluten intolerance, or your gut microbiome.
Take a more active role in tracking your health and take 20% off your first order of a mail-in testing opportunity with the discount code PEOPLE. That's PEOPLE, all uppercase. To learn more, go to Verizana.com. That's Verisana.com. Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon.
The People's Pharmacy is brought to you in part by Kaya Biotics, probiotic products made in Germany from certified organic ingredients. KAYA Biotics.com.
And by Cocovia, the maker of high-potency cocoflavanol supplements that support cognitive and cardiovascular health. More information at cocovia.com.
Also by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at Verisana.com.
Today we are talking toxicology. Lest you think this is an esoteric topic, the chemicals we are discussing are almost assuredly circulating in your bloodstream. How did they get there? What are they doing to you? What about your children and your children's children?
Our guest is Dr. Linda Birnbaum, Scientist Emeritus and former Director of the National Institute of Environmental Health Sciences and the National Toxicology Program. She served as President of the Society of Toxicology. Dr. Birnbaum was elected to the Institute of Medicine in 2010.
A lot of people go, okay, I've never been exposed to flame retardant as far as I know. I'm not using stain-resistant chemicals. How would it affect me? And I'm wondering, well, what about that new car smell? When you get into that new car and it's got fabric and they may coat it with something to prevent stains, or what about that new carpet that you put down? I mean,
what about your nonstick skillet? Does it have PFAS?
Well, I've gotten rid of my Teflon nonstick skillets within the past couple of years. I decided there was nothing wrong with my very, very old stainless steel that I was using. There are some products you can buy now that do not have PFAS in them, and I think that they may be perfectly good to use. I think you have to be a little careful because some of the ones will have big letters telling you there's no PFOA, which is one specific kind of PFAS. What that kind of tells you is that there's been another PFAS substituted for the PFOA. So I think you have to be careful when you look at it. But they are in skillets. I mean, I bought a new pair of hiking shoes recently, and the salesperson happily told me that these were totally water repellent. And I thought, that's really not what I want.
Because if it's water repellent?
Then it likely has PFAS.
So there are probably dozens, if not hundreds, of products in our homes that have some PFAS chemicals in them?
That's correct. And when studies have been done, and I would say the numbers of studies aren't tremendous. I mean, there have not thousands and thousands of studies of PFAS in, for example, house dust, but the studies that have been done show very significant levels of PFAS in our house dust. And we know that dust is a major exposure source.
Why should we be worried? What could these chemicals do to us?
There have been a wealth of studies in not only rats and mice, but other mammals, including non-human primates, in birds, in fish, and now hundreds of epidemiology studies, which are observational human studies, which have shown a wealth of different adverse health effects. The largest study that's been conducted to date was of a community near the Ohio River in West Virginia and Ohio called the C8 study. And in this study, a panel of scientists were set up as part of a legal settlement. And these scientists conducted a number of studies, and they came out concluding that there was strong evidence for associations with testicular and kidney cancer, liver effects, elevated cholesterol, effects on hypertension during pregnancy, which is a growing problem in this country.
And can be life-threatening.
And definitely can be life-threatening both to the mother and the baby, and also effects on inflammation of the bowel. Those were the ones that they felt that in their population they had the strongest evidence. There are now multiple studies from different investigators looking at different populations showing suppression of the immune system from exposure to these chemicals. And again, when I see something that is observed in human studies, and we have the same thing going on in multiple animal studies, that increases my confidence that there's really something going on here. So it seems to me that the data is quite clear that these chemicals can have adverse effects on people as well as wildlife.
Now, of course, as a pharmacologist, we like mechanisms. Have we figured out what's going on with PFAS chemicals in the body?
I think there are a number of ideas that are circulating, a number of things that are being looked at. We can see that PFAS are associated with changes in epigenetics. Epigenetics actually control what genes are turned on when, and if something impacts that, it's going to have an effect. We've seen effects on oxidative stress. We've seen a variety of mechanisms I would just say they're being investigated at this point. There's not going to be one mechanism. I should say that. PFAS impact multiple hormone systems in our body, different signaling systems, both nuclear receptors and things that are on the cell membrane. And it's not just one receptor. So I sometimes call PFAS the dioxins of the 21st century. But frankly, I think they're a lot more complicated.
Now, you've gotten into, shall I say, a little bit of trouble because you've been encouraged to use the word association. And in fact, scientists love to use the word association. You know, this is associated with that. But the idea that it might do more than be or have more than just an association, that there might be a causative effect. In other words, does A associated with B or does A cause B?
Well, for that, you need a different type of study, right?
Maybe. I think we would all agree that lead impacts IQ.
Yeah.
There's never been a randomized, double-blind controlled trial of lead.
Because that
Thank
would be
goodness.
unethical.
That would be unethical. I think we all would agree that smoking can cause lung cancer. There's never been a randomized double-blind control of smoking and lung cancer. And yet when the information, the wealth of data builds up from many, many observational human studies, and when you have data in animal species, and I would say a wide variety of animals that basically are showing you the same response, that's when you can begin to talk about causation. I think that, for example, one of the most important things is we have what's called longitudinal perspective human studies, so that you know that exposure occurred at a certain point in time, and you're looking for the effect not at that same time, because that's an acute effect. Really what we're most concerned about with these class of chemicals is what's happening from chronic low-level exposure.
Over decades.
Over decades would correct.
Now, many years ago, we had a conversation about BPA, bisphenol A, with an industry scientist. He was head of the trade association that was associated with that. And he basically made the argument, well, the dose makes the poison. You're exposed to such low levels of BPA, nothing to worry about. Tell us a little bit about the dose effect curve and a little bit more about why low doses may not be so safe after all.
The idea that the dose makes the poison comes from the 1500s when Paracelsus basically created that phrase, in Italian, I should say. But I think that we understand today that different things happen at different doses. Different mechanisms get activated at different doses. It's very important to think of that. So things can happen at very low doses. We need to understand that many of the things that happen at very low doses are things that are impacting our endocrine system. And our hormones, they control who we are. As adults, they maintain our basic physiology. But during development, they're absolutely essential for normal development. And hormones work at incredibly low doses. And we now find that perturbations of our hormone systems that occur at very low doses, that's one mechanism. As you increase the dose, you bring in other kinds of mechanisms which may cause very different kinds of effects. It kind of surprises me where people don't want to recognize the issues or find it difficult to understand that different things happen at different doses. We've known for years that different things happen with vitamins. Too little is a problem, too much is a problem. Same thing is true, for example, with essential metals. You know, you need a little bit of manganese in your body. You need a little bit of copper. You need a little bit of zinc. If you don't have any of that, you're not going to be healthy. But if you have too much, then you have toxicity. So I think we need to understand, especially the fact that things can happen at low doses and not expect them to be the same thing that we would see at increasing levels.
Well, let's get specific about BPA. We find it in, it used to be part of popular plastic containers. Baby bottles were made with BPA, water bottles were made with BPA. Perhaps they're not so frequently made with BPA now, bisphenol A, but your canned food is probably lined with a plastic to keep the metal and the contents of the can from touching each other. And that plastic may very well have BPA or a related compound. Should we be concerned?
Well, the Japanese stopped using BPA in their epoxy resin in cans. It's got to be 15 years ago or more. There are some alternatives. I think we need to understand that if you have canned food, you don't want bacteria getting into the food.
Right.
And that's why something has been added to provide safety along those lines. The problem with BPA has been removed from baby bottles and sippy cups, and it's been removed, as you said, from many, say, water bottles and so on. It is still present to some extent in like cash register, the thermal cash register receipts. But there are many substitutes that are being made. And the problem, this is where we get into the topic of unfortunate substitutions. Some people call it whack-a-mole or the chemical conveyor belt, where we go from one chemical, which we have evidence causes a problem, to another very, very related chemical that we just don't have any data. And I think that's part of the problem that we're dealing. So now many things have BPS or BPAF or BPF or BPB, and I could go through a whole alphabet soup of alternatives.
Well, this brings us to the precautionary principle, something that the Europeans have been, I think, ahead of us, where you have to prove safety before you can market the product. Here, you can market the product, I think, and then wait for the research to prove that it's safe or harmful.
So we have a very different regulatory system in the U.S., where often things, first of all, if anything was made before about 1976 or 77, it's allowed to be used. And then we really do wait for evidence of harm instead of showing evidence of safety before we start using it. I think the precautionary principle in the U.S. has been misunderstood, frankly. The precautionary principle does not say you act in the total absence of evidence. It says you act in the presence of concerning evidence, but not certainty. And I might suggest that science is rarely certain.
So in Europe, the precautionary principle would suggest, let's not use this chemical because it looks worrisome. Whereas in the U.S., we might say, well, this might look worrisome, but we don't have the absolute data to say that it's a problem, so we'll keep using it.
I think that's fair. I think we as kind of the entire scientific establishment hasn't been thinking about the fact that if you can substitute one chemical for another and it doesn't require any change in, say, your industrial process, why would we think that it wouldn't have similar effects in the body? And we're beginning to find that that's true as well.
So are there some things we should avoid? Like, should we not get a can of stain-resistant spray-on chemicals and spray them all over our upholstery in our cars? Should we be thoughtful about the kinds of carpets that we put down? I mean, are there some things that we can do?
So the answer is, if the two examples you just gave are absolutely yes. I know that I used to happily spray, say, my winter boots or my shoes, and I would spray my new tablecloths to prevent stains. I don't do that anymore because now I realize that's not something that may be good for my health or the health of my family in the long run.
Should we give up carpet?
I don't think there's any reason to, because many of the carpet companies now are not using the stain repellent material on them anymore.
PFAS is now out of some carpets. So maybe we should ask the question.
I think we can. This was done with certain kinds of flame retardants about 15 years ago, where people began to be concerned about some of the brominated flame retardants. And I can remember going to buy a new mattress and saying, are there any flame retardants in my mattress? And they pulled out a sheet which showed me that there were no more of the brominated. What they didn't tell me, and I didn't know enough to ask at the time, is, well, what about some of the other flame retardants? So I think this is an example where we as consumers need to demand more information in the product about the products that we want to buy.
And if we wanted to know what products had PFAS, what are the chemicals, the names that you're familiar with that we wouldn't be able to even pronounce?
Well, things like PFOA and PFOS.
What does that stand for?
Well, PFOA is perfluorinated octanoic acid.
See?
Right. It's, and the other is perfluorooctanoic sulfonic acid. I think I'm right there.
I think most of us would probably stumble because we wouldn't know what the heck they were.
Correct. And you won't see them in products that are made today because the companies that were making them stopped producing them. Some of them in about 2002, and some of them in about 2013. But you'll see things that instead of whether they'd spell it all out or they would say PFHXS or PFHXA or fluorotelomere alcohols. If you see a word fluoro in there, that's an indication.
You're listening to Dr. Linda Birnbaum, Scientist Emeritus and former Director of the National Institute of Environmental Health Sciences and the National Toxicology Program. She has also served as President of the Society of Toxicology. Dr. Birnbaum was elected to the Institute of Medicine in 2010.
A recent study suggests that children and young adults with higher exposure to certain chemicals, including PFAS, are far more likely to develop celiac disease. This autoimmune condition has increased a lot over the past several decades.
The research conducted by the NYU Grossman School of Medicine found that young women with high levels of PFAS were 5 to 9 times more likely to be diagnosed with celiac disease than those with low levels. Among young men, high levels of chemicals from flame retardants doubled the chance of a celiac diagnosis. Youngsters with elevated levels of pesticide-like compounds called DDEs were twice as likely to develop celiac disease.
After the break, we'll take a look at some pesticides like glyphosate, aka Roundup for killing weeds, and chlorpyrifos for killing bugs.
How have European countries regulated chlorpyrifos?
Industry has responded negatively to any criticism of glyphosate. What does science tell us?
Some consumers think checking out pesticides is just too complicated and requires command of too many unfamiliar details. What's the big picture?
We'll find out, and we'll also discuss the possible role of regulation.
You're listening to The People's Pharmacy with Joe and Terry Graydon.
The People's Pharmacy podcast is sponsored in part by Kaya Biotics. KAYA Biotics offers the first probiotics which are both certified organic and hypoallergenic.
All probiotics are produced in Germany under laboratory conditions with high-quality ingredients and under strict regulatory oversight.
The 3 available formulas are created for very specific purposes, such as strengthening the immune system, fighting yeast infections, and helping with weight loss.
To learn more about Kaya Biotics probiotics and the important topic of gut health, you can visit their website, KayaBiotics.com. That's KAYA Biotics.com. Use the discount code PEOPLE for $10 off your first purchase.
Welcome back to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. The People's Pharmacy is brought to you in part by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at verisana.com.
And by Kaya Biotics, probiotic products made in Germany from certified organic ingredients. KAYA Biotics.com.
Today, we're talking about common chemicals found in your house, in your food, and most importantly, in your body. Our guest is one of the world's foremost toxicologists.
Dr. Linda Birnbaum is Scientist Emeritus and former Director of the National Institute of Environmental Health Sciences and National Toxicology Program. She has also served as President of the Society of Toxicology.
Dr. Birnbaum, I'm curious about a couple of agricultural chemicals that have gotten a lot of attention, and I'm wondering if you can fill us in a bit on whether or not we might be concerned about them. One is called chlorpyrifos. As I understand, it's an insecticide.
Maybe it's an herbicide.
Well,
pesticide.
glyphosate.
Let's just call it a pesticide.
Pesticide. Okay.
And glyphosate for sure is an herbicide.
So let's get these terms right. What's the difference?
Well, pesticide is the broad term. That includes insecticides and fungicides and herbicides, and then you have the specific characters under that, the specific types.
Mm-hmm.
So what was the chemical, Terry?
Well, one is chlorpyrifos. The other is glyphosate. Glyphosate is pretty well known by its trade name Roundup, and it has been associated with a lot of genetically modified organisms because companies have produced seeds to make plants that are resistant to Roundup, so you can spray this stuff everywhere and it's supposed to kill the weeds and not the crop.
So that's a whole new approach that's being taken with many different pesticides to make them more selective so that they don't. Of course, pests are pretty amazing and they develop resistance very, very rapidly. So you often have to change the formulations several times during a season. Chlorpyrifos was actually banned from household use in about 2002, I believe, because of concerns about its safety. We know it's what's called an organophosphate pesticide. So at least in adults, it inhibits acetylcholinesterase, which is a very critical enzyme in how our nerves function. But what we understand today is developmentally, it acts by a very different mechanism and at much lower doses. So chlorpyrifos can still be used in agricultural settings. Of course, things that are used in agriculture don't stay in agriculture. They migrate. They get into people's homes who are living near fields. They also can be on products. They're also used, for example, on golf courses and that kind of thing. Now, NIEHS, 3 of our grantees at our Children's Environmental Health Centers that we co-sponsored with EPA, in 2014, I believe it was, published 3 papers back-to-back in Environmental Health Perspectives, all showing essentially the same effect, that low levels of chlorpyrifos were affecting neurodevelopment in children, so that we found that children had lower IQ and also behavioral problems. These were only 3 of many other studies These 3 studies were done in different parts of our country with different populations, different ethnic groups and racial groups. These kinds of studies have now been shown in Asian populations and European populations, so this is a general understanding. And EPA in 2015 basically reevaluated all the data and basically proposed in 2016 a total ban on use of chlorpyrifos. Unfortunately, that was revoked in 2017 by the administrator of EPA at that time, Scott Pruitt. So there's still chlorpyrifos being used in large amounts in non-home ways, but that doesn't mean it doesn't get into our homes. I mean, there are also studies that show that children, for example, living in agricultural areas have higher levels of chlorpyrifos in their urine.
And what about Europe? What did they do?
It's been banned in Europe for a long time. There are other things like atrazine, which is banned in Europe but still allowed here in the U.S. The other one that you mentioned is glyphosate, and that Roundup is the trade name for much of it. The concern for that came about in part because the International Agency for Research on Cancer, which is part of WHO and holds what I would say is the most unbiased evaluations about the potential carcinogenicity of chemicals, concluded, I believe it was in 2015, that glyphosate was, I'm trying to remember whether it was 2A or 2B, probably or possibly related to cancer, to an increased risk of cancer. WHO scientists, IARC, and looked at a huge number of different studies that were, again, done in many different parts of the world, both animal studies and epidemiological investigations to make that decision. They included in their studies where they looked at Roundup in the experimental studies. And by that I mean the formulation. So not just the pure chemical. Now, I should mention that our pesticide laws require treatment of the pure chemical, not of the formulation to which we actually get exposed. And frequently what has been found is the formulation that causes problems, not so much the pure chemical. So I'm not sure that we have a 100% surety that glyphosate is the bad actor, but I think the data is quite strong that what people actually get exposed to, which is this formulation, is associated with adverse health effects. And I should say that in the NIEHS EPA-sponsored agricultural health study, which is a study of 50,000 farmers in North Carolina and Iowa, which started in 1993 and 94, there are other adverse health effects that have been associated with exposure to glyphosate, as well as they did see in the most recent cancer evaluation a small increase in one kind of cancer associated with glyphosate, and you can measure the glyphosate or their metabolites in the urine. You don't look at the entire formulation. And so I think that's where some of the confusion or the disagreement comes from.
The industry has pushed back, and industry scientists have said, don't worry, not a problem.
Isn't that what industry scientists always say?
Well, that gets us into the whole issue of science, because we like to think of science and scientists as pure, as relying exclusively on the data and not on pressure from whoever's paying the bills.
Scientists are just people, and we all are impacted by who pays our bills, whether it's you get a grant from the NIH or you get a grant from industry. Science is more than just data. Science is the interpretation of data where you bring your entire life viewpoint to look at the data. I think over time, the interpretation of data comes down and basically consensus evolves. And I think we need to understand consensus does not mean everybody. Consensus is a large majority. So I think that that's part of the issue. There are many very good scientists who work for industry. I think it's important that we don't demonize, but I think that there are scientists whose interpretation of the data is impacted by their desire to get the next contract.
Dr. Birnbaum, there are a lot of consumers who say, oh, well, everything causes cancer. You know, we're exposed to thousands of things. I can't be worried about any of that. You know, I'll just let chips fall where they may. How do you respond?
I can understand that concern or that lack of concern, but I'm a pragmatist, so I do things that make sense to me, and that can be done relatively easily. So I mentioned that I got rid of my Teflon pans, not because I was sure that they were going to kill me or do something terrible, but because it was easy and there was an alternative that I could use. I stopped microwaving in plastic, my goodness, almost 30 years ago. Not because I was sure that the chemicals that were in the plastic were migrating into my food, but because there were all kinds of easy alternatives. I could use, ceramics. I could use paper rather than plastic, for example, to do microwaving. So I think there are times that we do use chemicals that we know may be problematic because we see a benefit. So I hate to say this, but my husband still uses Roundup to go out and kill the poison ivy.
Poison ivy.
That is growing around my house because he's really, really allergic. And so we do that because you have two alternatives and you say, well, I'll choose the one that is going to be less immediate anyway in its adverse effects. So I think that we have to realize that just like drugs, where we're willing to accept certain risks associated with drugs for the benefits, I think we have to look at some of our environmental chemicals and ask the same question.
As you look back on a wonderful career, can you share the big picture with us, please?
So I think what we understand today about our health and the environment and environmental health is that nothing is just genes and nothing is just environment.
So nature, nurture, it's always both.
It's always both. Certain kinds of health conditions may be more one than the other. And we know that many of the chronic, non-communicable health conditions, which are responsible for the greatest amount of sickness and death, not only in the United States, but in most of the world, do have a strong environmental component. But it's also your underlying genetics that makes a difference.
Well, I'd like to get to the idea of regulation because I won't say you were hamstrung at the NIEHS, but your job was science, research. You couldn't make regulations quite like the EPA or the FDA could. We've been, in the last few years, under, I'd say, a not maybe laissez-faire approach, but regulations have been anathema. In other words, let industry be industry. Let them do what they need to do for the economy. What about the big picture, the long-range goal of reducing exposure, both in the water and the air, as well as in the dust that we're exposed to? Where is the role for regulation, and do you see that changing in the future?
I think regulations are important to provide guidance for the direction in which we need to go. What I've always been kind of amazed at, there's been lots of economic analyses have been done, for example, about the regulations related to air pollution. And invariably, when you look at the cost of health care and lost lives due to, for example, air pollution impacts, lost IQ, increased diabetes, increased cardiovascular disease, increased lung disease, effects on our immune system, when you look at those costs, they far exceed the costs of the regulation. When we switch from one industry, which is pretty dirty, and we develop a new industry, actually the economy does better and the industries do better. But I think just like most people, there's a resistance to change and there's fear of the unknown. And I think that plays a role into the resistance to regulations. But I know that many of us are terribly concerned about our planet and the future of our planet with climate change absolutely occurring at this time.
I'm wondering which compounds you are most concerned about and what we can do about them.
Well, there's kind of a laundry list, but I would say the PFAS are kind of at the top of my list right now because they continue to be made. Many of the ones that are being made today, they kind of fall in two classes. One are what's called the short chains, and they don't stay very long in our bodies, but they will stay forever in the environment. And if they stay forever in the environment, they're going to reach higher and higher concentrations that interact with our bodies. The other is there's a lot of use of polymers. Now, polymers are where you hook together many small molecules, like many of these small PFAS, and make a big, long one. And what I've heard from colleagues in industry is, well, this is great. You'll never get these into your body. They're not going to cause any health effects in your body. The problem is you have to make them, and there's always some escape of the monomers in the production. Some of them break down. Some of them have side chains that break off, and they turn out to be these PFAS. And then I think, do we really want to make more styrofoam? Except now it's called a PFAS-containing polymer, something that will still be with us a million years from now. You know, we learned in the 1960s with Silent Spring, and then the 70s, understanding more about DDT and PCBs and dioxins, that we don't want chemicals that will never go away. So I am frankly amazed by our continued production of chemicals that will be with us, certainly for the foreseeable future, if not forever. And then I think there are other, are beginning to understand more and more about chemicals that interfere with our endocrine systems at very low levels. I think those are the other kinds of chemicals that I have a great deal of concern about as we go forward.
Dr. Linda Birnbaum, thank you so much for talking with us on the People's Pharmacy today.
Thank you for having me.
You've been listening to Dr. Linda Birnbaum. Having retired, she's scientist emeritus and former director of the National Institute of Environmental Health Sciences and the National Toxicology Program. She has also served as president of the Society of Toxicology.
Lynn Siegel produced today's show. Al Wadarski engineered. Dave Graydon edits our interviews.
The People's Pharmacy is produced at the studios of North Carolina Public Radio, WUNC. This week, part of the show was recorded from our home studio.
The People's Pharmacy theme music is by B.J. Liederman.
The People's Pharmacy is brought to you in part by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at verisana.com.
And by CocoVia, offering plant-based nutrients in the form of cocoflavanols for brain and heart health. Online at cocovia.com.
Also by Kaya Biotics, probiotic products made in Germany from certified organic ingredients. KAYA Biotics.com.
To buy a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is number 1212. The number again, 800-732-2334, or on the web at peoplespharmacy.com.
When you visit our site, you can share your thoughts about today's show. Are there pesticides you worry about? Have you been thinking about PFAS?
You can subscribe to the podcast at peoplespharmacy.com or wherever you get your podcasts. We would be ever so grateful for a review. When you visit the website, you can also sign up for our free online newsletter to get the latest news about COVID-19 and other health stories.
Next week, we'll be talking with Dr. Steve Nissen. He's Chief Academic Officer of the Seidel and Arnold Miller Family Heart, Vascular, and Thoracic Institute at the Cleveland Clinic. His book, co-authored with Dr. Mark Gillinoff, is Heart 411, the only guide to heart health you'll ever need. He will tell us how SARS-2 affects the heart. He'll also discuss his disappointment in the remdesivir trial and and he will offer his concerns about the heart rhythm effects of hydroxychloroquine and azithromycin.
We'll also learn why you might not need a stent unless you're having a heart attack. In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thank you for listening. Please join us again next week. Thank you for listening to the People's Pharmacy Podcast. It's an honor and a pleasure to bring you our award-winning program week in and week out. But producing and distributing this show as a free podcast takes time and costs money.
If you like what we do and you'd like to help us continue to produce high-quality, independent healthcare journalism, please consider chipping in.
All you have to do is go to peoplespharmacy.com/donate.
Whether it's just one time or a monthly donation, you can be part of the team that makes this show possible. Thank you for your continued loyalty and support. We couldn't make our show without you.